Hi there. I guess this would be, I wouldn't call it an addendum to the last one. Uh, there's a lot of, I've written a lot of code uh, and did enough work on different things, various things. There are enough topics, maybe too many topics to cover that are related, certainly, to this problem with the XML file or dealing with XML files. But just these are general problems and solutions that come up. Well, my solutions anyway, in this case, that tend to come up repeatedly. That is, I mean, the solutions are often the same, and it's all to do with organization of data and making sure that one part of the code doesn't modify something it shouldn't, and that you can have easy access to the data, and that it's fairly intuitive and that sort of thing. And I think I've managed to do that, although not in the way I had intended. I think I said, and I know I said last time that I started when I was trying to think about the structure of this thing, the tree with all the nodes and everything, that I started with a function called cleanup. And that function is gone. And I don't really know why, but I wanted to get the thing working. And when I was walking through the tree and going through the parents and the children and the siblings and trying to delete all the nodes, somehow there was a memory leak. So there was a bug I assume, in the way I was traversing that tree, right? Like it would stop at some point. I know that all the data is in the tree and accessible. I wasn't walking it the right way. So I said to myself, just to get it working, I know when I'm making the nodes. So I'll make a list. Every time I make a node, I'll add it to the list. And at the end of the day, I'll just delete everything in that list instead of trying to walk this complicated tree. And of course, that works fine. So now that's in a sense a kind of data duplication. It's all of the information in order to delete all of the nodes is contained from the first node, right? So I don't need an extra list. On the other hand, I wanted to get it working, and that was the simplest way to do the cleanup. But of course, that in turn introduces the possibility of bugs, because you have the node structure itself, which is fixed and never changing, and the only real reference that one should use, and then this other thing that might get out of sync. So I use some of what I would consider advanced techniques to try to minimize the possibility of error or bugs to do with that kind of duplication, and I'll get to those in a minute. One of the things that came up first off was just to do with the file I'm using for my testing. This here. No, hang on a second. It's funny, I say hang on a sec because I'm going to go and make a coffee and do some things around the house. But of course, for you, there is no time left. So I don't really need to say that, do I? Alt option. Okay. So here's our famous file. As I was looking at this, I kept looking at this thing and thinking, how hard can it be? There must be more. This must be a standard thing. In fact, it is a standard thing. This format, okay, is called base 64. Is what it's called, and the reason it's called that is what the way this thing works is it takes 64 well-known printable characters that can appear in an ANSI text file and maps those to values from 0 to 255. So it's one of those ways of converting binary to text so that you can hold binary values in a text file, and there won't be any zeros or control characters or anything like that. This isn't the only method, but it's one of them. It's actually not that inefficient. The the amount of data for these characters is four of these characters, which is 4 bytes, corresponds with 3 bytes worth of data. So it's either a 1/4 loss or a 1/3 loss, depending on which way you look at it. Take it somewhere in the middle. Let's see. If your data is 3 bytes and you have to spend 4, so that's a third, right? It's a 30% increase in size, but that's not too bad, considering something like Unicode, which is more like a 50% increase in size for for European, for most of the world. Well, I can't say most of the world. Asia is most of the world, really, and so that there are probably more computers in China than all of Europe. But I don't care about them. For the important people like us who use Latin alphabets, sensible things, it's a doubling of size to use Unicode. That's why they have, UTF-8 is a good thing. It's one of the reasons. Anyway, so this thing's called base 64. And I looked it up online. Actually, I started writing the code for it. Once I saw the word base, like I looked up binary data in XML files, and it said base 64, and I immediately started writing down what I thought was the code, and it was almost exactly what they do. Actually, I have something that already that does something similar to this kind of encoding, where you take a smaller character set and map a larger one into it. And actually, it's still online. I have it here saved for this tutorial, so you can have a look. This is I have no server to run this on except for this one. I used to have an Apache server installed on here, and maybe I'll reinstall it. I started making this little page, and I was going to do some things with it a long time ago, like to do with articles and whatnot. So that was the outline of this page. Was it was going to be like a news articles that would get updated, and I learned how to make these things, the rollovers and whatnot. But one of the things I have here is this thing called the cipher. And that was when I was learning how to do JavaScript. Go there. Okay. Now this here is written using JavaScript. And I think I may have explained this in another video. It's an encryption type thing that was used in the American Civil War, in particular. V stands for a name with the person who invented this cipher. A cipher is something that encrypts. And I have his name. I have all people, sort of relevant people that I know about. In here, no, it's V. So we did here into S. So V. It should be here. Oh, here it is. That's Volta is in the wrong place. Yeah. I hate that. Especially when it's taking this long. Oh, I actually clicked on that. I just want to move this. Go up here. Okay, trying to get back to I don't know how to pronounce it. Vignier. Blaise de Vignier invented a cipher, a thing that ciphers, and when things are ciphered, it is the job of the decryptor to decipher the jumbled characters, and his Vignier. Maybe there's an audio button. Some of these things sometimes have a Vignier. It's a very simple idea. They don't have a picture, and I showed a video of it. You take the alphabet A to Z, capitals, and you think up of like a keyword, and then you use the table to map the letters using the keyword in a very simple way, which is outlined in this article. Now I wanted to use that's great. Here's the table of all the characters. Right? Let me explain how you do it. So you just take A to Z, right? And then the next row you start with B, and you rotate them, so you end up with this table like this, right? And then to encode something using an encryption key, you match up the letters as you go along. Like if this is the message, if this is the message and the key is lemon, you repeat the letters lemon, 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 and so then you combine these things, A, and you combine with L, and then that gives you a result. You go A, and then you go down to L, and you know, in this case, you're just going to get L. But for T goes along with an E, so you would go to T, and then down to E, and the answer is X, right? And you just lay out lemon, 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 lemon repeatedly throughout the entire message, and run through that algorithm, and you can make a jumbled thing into a secret code. See, here's what it comes out as. Well, I wanted to do the same thing, but I wanted to be able to put any characters. So in the same way, in an analogous way, where this uses 64 characters to map an arbitrary byte, right, 0 to 255. This uses only 26 and maps any ANSI character doesn't matter what. And same for the key. So I'll show you. Suppose I take this source code here. That'll be my message. Okay. So here's my message. It wraps, but it's okay. They're not resizable. Now, for the encryption key, I can use anything I want. Anything ANSI. I could use, here's a key. Okay. So now I got my key, and I got my message, so then I push encrypt, and here is my encrypted message. And as you can see, it's only letters capital letters A to Z, and in this case, 445 of them. Now, let me just write down the key here, just so you don't think that I'm trying to fool you. And we'll put it into this file. Close this thing down so it's not remembered anything, and I can clear the cache. I can clear the cache. I'm not going to clear I don't want to clear my passwords. Actually, I put all my settings things here. It's quite useful. Plugins, history. I want to clear this cache. You can do that. You can make yourself a settings menu in Chrome, because all of their settings are web pages. They're in the form of a web page, so you can bookmark them. Okay, now let's see. Now if I clear this, what do I get? This is going to take a few videos, because I don't want to speed along. Might as well have some fun with it too. So that's just images and okay, form data. Too bad. Cookies. Now, does that mean I have to type my passwords in again? No, it will remember my passwords. So I'll clear that. Alright, I'll shut it down. So now all I've got is this encrypted message and this password. And in theory, if my thing works, it should turn back into that source code that I encrypted. So we'll start it up. It's too bad to lose the server. I'm sure that if anybody knows of a site, like a free site where you can place a web page on, and just for testing things, and I really appreciate knowing about it. Even if it's got ads, well, it depends. If the page is in such a way that you can't do whatever you want, then it's not much use. Okay, now I'm going to go back to the same page, which is Twilight Games, Allen 10th. That's the entry page. You click on the V cipher. Okay, now this is either message. Well, it's the message. It's still a message. It's encrypted. So I'll take the message, paste it in here, and now this is encrypting. I want to decrypt, so I need the password, which is this. Decrypt, and how do I select all of it? It used to be a single click. I had set it up that way. I guess it doesn't work anymore. I'll go here. So the message is this. See? So I converted that with this password into that. And then this is another example of taking a large set of characters, with arrows and brackets and colons and slashes and whatever, and mapping it to only 26 characters, which means that there's an increase in size. And this, in fact, if I get rid of this part, and it doesn't tell me how many characters, but let's see, that's 80, 100 something, less than 200, and it went up to 400 and something. Right? It doubles it basically. So in that sense, this base 64 thing is pretty good. There's only a 30% loss, 100% loss. It's double the size, so it's 100% more, I guess. I don't know how one puts it. Well, so I read about it, and it's not in my history anymore, but binary, oh, it is. How about that? I thought I deleted my history. Okay, anyway, I click on here. Just trying to find out what the algorithm is, and I had guessed that okay, they've chosen 64 printable characters to map any character, and in fact that's what it says here. It also says that this article is confusing and doesn't have section headers and needs a lot of cleanup, and that's true as well. But it does say a couple of the magic words for, well, this I just guessed. But well, here, this is the mapping. Okay. In fact, I didn't even notice this before. But I guess this was my first guess, right? The 8, because if you look at the data, I figured A is probably 0, right? And so therefore, capital A to capital Z must mean 0 to 25, right? And then I figured they'd probably do small letters, and then I found out that they include numbers, and 2 extra characters because you're missing 2. In fact, they lay it out here exactly. A to Z with capitals, then small a to Z, then 0 to 9, and now that gives you 62 values, and we need 2 more. So I look back here, and I look through for anything extra, and I see a slash and a plus. So that's the full set. What I didn't realize is the equal sign is used for padding, but that's okay. No big deal. And I had coded it, and I thought I'd coded it right, and I was taking this data, and it wasn't turning into an icon, and I was getting frustrated, and I just wanted to see if it was an icon or not. And finally, well, not finally, eventually, I just typed in the same thing, but I added C++. I just wanted to grab some code that will compile and just see. I'd see at least if it matched what I had. So let's see now, base here. And it turns out that the snippet of code that you're about to see must be the sum total of all, the only code used for this encoding and decoding in base 64. Okay, word for word. Here's the one. And immediately I didn't like this because, well, for one, it didn't look like mine. And for another, it's using the standard string, which I hate. And for another, it's not T cars, it's cars. And for another, the variable names are ugly, like in underscore, and I and J, like if I, what the hell is I? At this point in a function, what's I? And then here it is again. More of it, right? I don't know why I thought, well, there must be something. I started copying that, and I thought there must be a better one than that. And you can see where I clicked. Let's see now. Decimal to binary. And hey, look at that. Look familiar? There it is. Exactly the same code. I even copied it and was starting to, because I thought mine wasn't working. In fact, it was a slight bug. Here again, same, see? Exactly the same. If there's a bug in this, there's a bug in everyone's code. Let's see, that one. I was just trying to find one that didn't use, standard string and all that. Let's see if there's another one. Yeah, none of them looked like mine, and I thought mine was pretty much, except for a possible bug, it just needed a little fix. Now look at this. I don't know. I'll show you my version first. You can see why I don't like any of those. It wound up in TS string. Because I have other kinds of conversion things. So it's not that. Now there's this. Here's the thing that does the mapping. A to capital Z ranges from 0 to 25. So you pass in. I'm trying to decode these values, right? So a capital A should come back as 0. So if the byte passed in is between A and Z, I subtract A and return that, right? Otherwise, if it's in this range, I subtract a little a And now I'm at index number 26, so I've got to add 26, right? Now that takes us all the way up to 51. Then there's the digits, which would start at index 52. So that's the code for that part. And then there are the two remaining characters, and I just guessed one or the other. I didn't know. Hadn't noticed that table. Now here's my decoding algorithm. I didn't tell you before, I mentioned it only briefly, that I introduced a buffer class to my classes. And it's a very, very basic class. It doesn't do much, and I should add some more functionality to it. But it's handy for something like this, where you don't have to think about the size, right? You just pass it in, and it allocates the right size thing. But I'm using malloc, and I can take a malloc pointer and I can put it into one of these buffer things. All right. First, I was thinking that it's going to be a little bit complicated, because if you look back at the wiki one, it's like doing a bit shift. Oops. That's it. Like the characters are all between 0 and 63, so that's 6 bits, right? And so therefore, where that picture went? Is there a picture of the... Here. You see, you got 6 bits for one character, and now you've got an 8-bit byte. So then the next 2 bits of the next character are the last 2 bits of the first byte, and then those, it looks like it's going to be a complicated mess, but the cycle repeats after only 4 bytes, so it's quite easy. Here I've laid it out. I don't know what I call it. They're not cases. This is a encoding of 3 bytes into 4 ASCII characters, right? One way or the other, these are in groups of 6. Those are the ASCII characters, and there are 4 sets, X, Y, Z, and W, for the 4 characters. And there are 3 bytes as output. That's what I'm trying to generate. So after the 3 characters, you end up at the end, and so it just repeats. So all you got to do is encode or decode 3 bytes, and then you just do the same thing over again. Now it must be that this string, this is a string to begin with, has to be a multiple of 4 bytes in length. It turns out if it isn't, does it have that? Yeah. The equal sign denotes padding at the end, and you just return 0 in that case. So to make it a multiple of 4, you add enough equal signs to do that. Anyway, these are just assertions. Let's get rid of them. So here in my loop, my length is len, okay? So that means that the buffer, the output buffer is going to be 3/4 of len, right? Smaller. I get fewer bytes out and in, because I'm starting with these ones. How much time have I used? Quite a lot. It's okay though, no problem. I'll do this and then I'll go on to the next bit. Okay, so 3/4. I know exactly the size of the buffer, so I can allocate it immediately. And now I want to go through the loop. Now the loop is very simple. N pause, which I only had one to begin with, was meant to stand for the position in the string, in this string. Okay, that's N pause, and N pause buff is the position in the output buffer, current position, right? That's how I named them. This probably should say N pause stir, let's say. Now I'm just doing this in chunks, so one of these things per loop. So at the end of the loop, I increment my string position by 4 and my buffer position by 3, and then I work on the 3 bytes worth of output and 4 bytes worth of input in this one step. And it's not that hard, except it turned out that I had an F here instead of a 3. Let's see now. If suppose, well, actually my unit, well, I can do it easier just typing this one again. Well, I'll take an example from here. Let's suppose these are the 4 characters. I want to turn those into output. Okay, now A I know is 41 hex, so that's oops, that's a 4, and that's a 1. So that's A. E is 41, A, B, C, D, E, 45 hex. That's 4, and 5 is that. Okay. Oh, well, these ones are okay. No, the small letters, you don't go by their hex values. You're adding 26, right, to whatever the position of S is normally, and what position is S in the alphabet? I don't even know. I should use raw 13. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say it's 21 or something, okay? So 21 plus 26 is 47. And so in hex, that's 2F, 2 and F. And the next one is a 6, which starts at, the numbers start at 26, 46 is 40, 50, 52. 52 plus 6, so 58. 58, 3A. A. 8, 9, 8. Okay, so here's our input, and I'm not going to go through any mathematical calculation. I'm just going to show. Hang on a second. This A is wrong. A is 0, and so is E wrong. E is just A, B, C, 0, 1, 2, 3. It's 4, not 5. Because they can't be more than 6 bits. Whoops. Alright. Alright. So that's the input. It's not the character code, it's they're just using these as offsets. Okay. So all you do now is, since the top 2 bits aren't used for the values, right? Just throw them away, and that's going to leave you with 24 bits, which is 3 bytes. So the answer is, we need 2 from here, and we need 4 from here, and we need, well, the rest should leave me with 8. Oh, it does. So the answer is 0, 0, 4, 8, B, and F, A, FA. See? That's all you do, and that's all this does in one step. And the buffer thing has a function called adopt. So it takes this, I give it the buffer, I tell it how big it is, and then that's done. That's my thing. Now you remember what that other thing looked like, right? And I was trying to get it compiling, and I knew I must have had it right. It's just some stupid thing that's wrong, and eventually I found out that it was that this was supposed to be an F, right? It was supposed to be a 3. F wouldn't make any sense, right? None of these things have bits in the upper 2 positions, so it has to be, if it's going to be a mask, it's not going to involve anything in the upper 2 bits. So I should have noticed right away that I was wrong, but I didn't. Got it to work, and this is the decoding algorithm. There's nothing to it. Let's see again. Let's see their crazy algorithm. I even copied it. I can't believe it. It's terrible. Here I was trying to decipher that code. Right? This one was easier to look at, wasn't it? Okay. Now, maybe it's easier, maybe not. They put them, line them all up in one string, and compute the offset in that string of a character, and that is its number, like I have, but I have a function. So then you have cars, and then you have an array of something, and it's hard to read. And I guess it's not that bad, but I don't like it. I prefer this. Alright, now without showing you the code, I can show you the use of the code. First, To make one of these XML parser things is just a matter of declaring it. It only accepts ANSI at the moment. So I use the function I already have to read a text file, and that tells me what the encoding is, and if the encoding is ANSI, everything's fine. Now I can just say file, parse, and then pass the data in, and then at this line I'm ready to extract data from the object. Now, in thinking about files like find first, find next, and that sort of thing, and the registry, I thought an interface would be to have a type of position, a p-void type thing that's like a position. Okay, so there's no type information in this here. All it is another way of saying p-void. See, declare handler. The object knows what it is, and that's good enough. Now, one of the functions I added is the only one actually for obtaining a node rather than searching through the thing. You can search through it yourself too, but this is something, a built-in search, which will find the first node that has this path. And this function, by the way, should take 2 arguments. There, see? The default, no. So I could take this position I already have and pass it back into this function, and it'll start searching after this position for the next one if there's more than one. So I can use that for multiple searches for the same thing. Okay, now if I get a position back, here I'm seeing if there are any attributes. It's binary storage is where these icon things are. Binary storage, and the keys are called binary. So I find the first NFC console file, binary storage, binary position. The position of the first one is a match. And first I check to see if it has any attributes. It doesn't. Sorry, it does. Sometimes they do. If it does, then I print it out. And if it so happens that the attributes, well, there's two that have a name. One icon large and one icon small. So why don't I do this twice? If it's large or small, if the attributes say that it's a large icon or a small icon, I get the data, which may have character returns in it, and in this case I certainly don't want them. And decode to base 64, open a file, remove f name from my program name, it leaves the directory where my program is, and I'm going to call this, well, this icon large and icon small. Why don't I just call it this, stir attribute. Now I can keep that name equals, but I won't. I want to stir token. I want to get rid of the name part. This just like the regular stir token. It returns one token, and the rest of the token is in string. So that's No, that's mode. No, that's mode. That's my file name and mode. Okay. So now this thing is going through a loop. If I find one, and if it happens to have this attribute name, I save the data, and then I go position is file dot get sibling of pause. So this is a way to walk through all of the siblings of the first one that we found, and as you'll see, it actually finds 8, but there are only 2 that have any names. Those names will be printed out, as you'll see in a second. And then I'm going to stop. And we'll see if we get any icon file. So I'm taking this data and using that base 64 algorithm, turning it into a binary struct. Oh, the thing that I discovered, yeah. The reason why it wasn't working before, and something I just guessed at, because I looked at the data and I saw BM. And you know BM is for a bitmap file, BM is the first 2 characters. When I cut off everything before the BM, I got an icon. Believe it or not. Although I only got one picture. You'll see it. I can at least step up to here so that you can see that it got past here. Okay, so we got in there. This was what was printed out. So console file icon large. Now basically, I should have now created a file with that name in here. And I've not written anything to it yet. Oh, there it is. It's empty. Now I'm searching for this BM. So I put a note here that I need to add some seeking functions and things to this buffer class to simplify this sort of thing. When I find the BM, I advance my data position to however many bytes that is, and write out however many bytes are left into the file. 10, run up to here. Okay, so it doesn't say, but there it is, BM6, right? So we're on the BM. I write it out, close the file, and here is a file. It doesn't look like an icon, does it? Oh, I should have called it .icon. See? There is your little gears. It's in the text file. And let me just add a .icon. Get it. Now, I'd say that's a pretty good, that's an easy interface to use. But a lot of complication went into the making of this interface as easy as it is, and as flexible as it is. And that you can walk the thing yourself. You can do this searching by siblings and children. Let's run the whole thing. You can go up and down the tree and whatnot, and it's completely open and flexible. So here's the small one, and here's the large one. And That's all I'm going to do. So, if you're bored, you can stop now. But well, I'm going to press the I'm going to pause this and wait. I just clicked on this. Wait for GIMP to open up, and then you can have a closer look. Okay, now there it is. Now to the gears. So now the question is, or one question anyway, is when I click on this thing or see it in Explorer, is this a picture it's using, or is it using the picture identified in that other section? The one that listed System 32 something DLL. And that's easy enough to test. All I got to do is modify this MSC file. It's in docs. Rename it back to MSC. Modify the internal icon and see which one it uses. So that's it for the using, and we'll get to the coding bit next time. Is there anything else I wanted to add? There's a bunch of things I want to add. I also have to close that twice, but I can't think of them. Doesn't matter. I'll take it slow. So, again, this is in the works. Code that's not completed. Things will probably change. But if you're interested, if anybody is interested and wants to have a look at this code, you can always send me a message, and I will send you, in one way or another, a zip file containing all of this source code. See you.